Hello everyone, welcome to the preparation strategy for the signals and systems subject. This is for GATE and ESE point of view. So I'm Aditya, faculty at ACE Engineering Academy. I have a master's degree from IIC Bangalore. So now what are we going to discuss in today's session? So this is what I have for you. The first thing is I'll talk about the syllabus and then the weightage of this subject for GATE and ESE, and then what is the order that you have to follow to learn this subject so that you can get the maximum marks in the examination. And then I'll talk about the reference books, the frequently asked questions by the students, and I'll try to answer those questions. So before I start this discussion, let me tell you one thing. This signals and systems course, if you want to learn this, if you want to score this, then you know what are the prerequisites? The prerequisites are you have to be good with addition. Yes, you have heard it correct. Additions, multiplications, integration, summation. If you are good at additions, multiplications, integration, summation, then you are going to master this course. So let's look at the syllabus. So as of now, I have GATE 2022 brochure with me. Okay, so GATE 2023 notification is yet to come. So what I have is GATE 2022 notification or the brochure with me. So I have provided the syllabus according to the GATE 2022. So if there are any modifications, then we will definitely update you. So we will also tell you what are the topics that are added, what are the topics that are removed, and what should be our strategy. So once the notification comes, we will definitely give you an update about it. So this is as per the GATE 2022 brochure. Let me read out the contents. Continuous time signals, Fourier series and Fourier transform, sampling theorem and application. Discrete time signals, where you have to learn about DTFT, DFT, Z transform, discrete time processing of continuous time signals. Earlier, there used to be something called FFT here. Okay, FFT, they have removed it from the GATE. However, if you are writing the other exams like ISRO, BARC, DRDO and other PSUs, you have to prepare that as well. So this is for which branch? This is for ECE. Okay, so this is common for, okay, this preparation strategy is common for ECE, electrical and instrumentation. I'll show their syllabus as well. So let me read out ECE syllabus. And then LTI systems. So the definition and the properties of this, the causality, stability, impulse response, convolution, poles, zeros, frequency response, group delay, phase delay. So I have copied this from the GATE brochure. So everyone should have this GATE brochure with you, okay, where the syllabus is clearly mentioned for all the topics, all the subjects, the syllabus is clearly mentioned. So you should carry a copy with you, okay. So this is for easy. Let's look at for electrical engineering. So what are the topics? The representation of continuous and discrete time signals, shifting, scaling, properties, linear time invariant and causal systems, Fourier series representation of continuous and discrete time periodic signals, sampling theorem, applications of Fourier transform for continuous and discrete time signals, Laplace, Z transform, RMS value calculation, average value calculation for any general periodic waveform. Now this particular course, okay, so if you learn this, then this is going to act like a basic block or the foundation for your power electronic course. This is for whom? This is for electrical students. Now for ECE students, this particular course is like a foundation for advanced subject like communication engineering. Okay, so if you understand this, then the next subject, that is communication, will become easy for you. So this is easy, electrical. Now look at instrumentation. So more or less you have the same syllabus. Let's look at this. Periodic, aperiodic and impulse signals, Laplace, Fourier, Z transforms, transfer function, frequency response of first and second order, linear time invariant systems, impulse response, convolution, correlation, discrete time systems. So impulse response, frequency response, pulse transfer function, DFT, FFT. Look, FFT is clearly mentioned in instrumentation syllabus, and the basics of IIR and FIR filters. So this is the syllabus for instrumentation students. What next? We are going to see the weightage. Okay, so let's look at what is the weightage of this subject for various exams like GATE and ESE. So here I have the weightage from 2019 to 2022. This is for ECE branch. So which subject are we looking? We are looking signals and systems. So where is signals and systems? So here is signals and systems. Look at the number of questions, number of 2-mark questions and 1-mark question. 2 2-mark question, 3 1-mark question, 3 2-mark question, 2 1-mark question. Consistently you are getting 5-6 questions every year. So on an average you see that 8 to 9 marks are asked from this subject. Now if you feel like you are just scoring 8 to 9 marks, then you are wrong, because this subject is going to be the prerequisite for a communication subject. Have a look at this, the number of questions asked in this. If you want to score this, then you have to master this. So you need a good understanding of this subject to understand this communication. So this is for ECE. Let's look for electrical engineering. So what's the weightage of this? So I have the weightage. So where is signals and systems? So here is signals and systems. Look at the recent questions. So 4 2 marks, 1 1 mark. Okay. So here also you have on an average 8 to 9 marks. So this is where we have signals and systems. Okay. So on an average you get 8 to 9 marks from this topic. Now look at this power electronics. Now the basics of this are needed to understand this power electronics, because in this course we focus on harmonics. We also focus on what is the power in those harmonics. So if you understand this, then this is going to be easy for you. So this is a prerequisite, okay? I mean, if you want to master this, then you need the knowledge of this, right? So this is for GATE, ECE and electrical. Now, let's see what's the weightage for ESE point of view. So when it comes to ESE, look at this. So in 2022, surprisingly, only 5 questions appeared, okay? In 2021, 13. On an average, we get 10 to 12 questions from this subject for ESE, that is engineering services, okay? So this, and look at this, again the communication subject, you have good weightage from this. So this is a basic course to understand that. So this is the weightage for signals and systems for ESE point of view. Let's look at what's the weightage of this for electrical engineering. So look at this, systems and signal processing, 2022 14, 2021 10, 11, 10. So good number, these are all good numbers. So on an average I can say 10 questions are appearing from this, okay. So this is for electrical engineering. Now apart from this, in the conventional, you are getting, for let's say for ECE point of view, on an average you are getting 60 marks from this subject. Now for electrical, even more, 70 to 80 marks from this subject. Even for instrumentation, okay, for instrumentation, like you will see the same number of questions for GATE point of view, okay. So this is the weightage of this subject for the various exams. Even for the other PSUs also, you have the, like in the same way, the number of questions appeared, okay, in the same proportions. What next? Let's look at what should be the order in which you have to read the subject, okay. See here, if you go through this way, you will never understand. So this is not the right way. Let's see what's the right way of learning this subject. Yes, so how do you read this, or how does one has to prepare this? What's the first topic? What next, right? So what's the procedure? Let's look at that. The first thing that you have to do is, you have to learn about elementary signals. So what are elementary signals? How do you do basic operations on signals? Okay, so that's what I'll be discussing. I mean, you are supposed to learn what are elementary signals and basic operations on those signals. So let me show you what are the basic signals. Basic signals like step signal, ramp signal, the most important one, that is the impulse and its properties. This is one of the most important thing. Impulse and its properties. So there are many properties of this impulse. So you have to learn each and every property in a detailed way. So we have few more signals. Let me write them one by one. So next, the most important ones, the sinusoids. So you must know what are sinusoids, like sine and cos. The next ones, rectangular and triangular pulses. Rectangular and triangular pulses. The next one is the signum. So we have a few more like sync x. Most of the students get confused with this sync x and the other one which is similar to this, which is sa x, okay, sampling function. So you must learn about these things. Apart from this, you should also focus on what are exponential signals, like exponentially increasing, exponentially decreasing, and then complex exponentials. Okay, complex sinusoids. So these are the elementary signals that you have to see. So let me once again read out this step, ramp, impulse and its properties. This is one of the most important discussion. Sinusoids, rectangular and triangular pulses, signum, sync and sa. You need to know the difference between them. And then exponentials, complex exponentials, complex sinusoids. So these are the things you have to learn, and also like these are all continuous time signals. So you should also know about discrete time signals. So an extension of this, so you have to know about this. And then the basic operations on these signals. What are the basic operations on these signals? Let me highlight them. Basic operations. Basic operations, like the first one is the time shifting. Second one is time scaling. And then time reversal. Then amplitude scaling. Amplitude scaling. So these are the basic operations on signals. So you must know how to shift a signal, how to do the time scaling, that is the compression and the expansion, the time reversal and the amplitude scaling. Suppose if I have to perform all this on a signal, what is the order that you will follow? Especially this two operations. Which two operations? This one and this one are very, very important. Why are they important? Because if you want to convolve two waveforms, you need to know how to do the reversal and how to do the shifting, because the convolution operation needs this time reversal and time shifting. So these are the basic operations on signals. So one must be having a clear, crystal and clear idea about this basic operations. So far what we looked at elementary signals and basic operations on them. The next one is classification of signals. How are signals classified? So let's check them. How are signals classified? So they are classified as follows. Periodic, and aperiodic, even and odd. You can even extend this even and odd for complex valued signals. You can even extend for complex valued signals, and that will be called even conjugate and odd conjugate. So you have to learn about what is even conjugate and odd conjugate. And the most important one is the energy and power signals. So let's write it here. This is the most important one. Energy and power calculations. So how do you find energy of a signal? How do you find power of a signal? Okay. They are classified as energy and power signals, periodic and aperiodic, even and odd. So we have few more classifications. Let me put them. And then we have causal and non-causal. Causal and non-causal signals, bounded and unbounded. Bounded and unbounded. Deterministic and random signals. Okay, so this is how the signals are classified. Deterministic and random signals. So now what are you supposed to learn? You are supposed to learn what are energy and power signals, what are even and odd. You can even extend it to complex valued signals, and you have to learn about what is a even conjugate and what is a odd conjugate. And then periodic and aperiodic. Now this is a very interesting. Students find it very interesting, because if I give you a periodic signal and I ask you to find the time period, how do you find it? How do you find the fundamental frequency? Suppose if I add two periodic signals and I ask you, is it periodic or not? How do you check it? If periodic, how do you find the fundamental time period of that? So it's a very interesting, and students find it very like when they solve, they are very much excited about these questions. And then causal and non-causal, bounded and unbounded, deterministic and random. So these are the classifications of signals. What next? We are going to discuss about classification of systems. So first we will learn what is a system and how are systems classified. So I'll just show you the classification of systems here. So they are classified as follows: linear and non-linear. Time invariant, okay, time invariant and time variant systems. So we simply call it as TI-TV systems. So the most important thing is they'll give their combination, like, is the system LTI or not? They'll ask you, is the system LTI or not? Apart from this, you should also look at what is a causal and non-causal system. Earlier, we have seen causal and non-causal signal. Now, you should also learn about what is a causal and non-causal system. Okay, and then stable and unstable systems. So let's see all the classification. So you are supposed to know about stable and unstable systems, invertible and non-invertible systems. Okay, so look at this: linear and non-linear, time invariant, time variant, causal, non-causal, stable, unstable, invertible, non-invertible. Should also know about static and dynamic. Static and dynamic systems. So this is how the systems are classified. So in this introduction section, you're supposed to learn all this. Okay, so this is what is in this introduction. Let's move on to the next topic, that is about linear time invariant systems. Okay, so let's look at this LTI systems. Now if I give you LTI, so what LTI stands for? It stands for linear time invariant. So if I give you a LTI system, how do you find the output response? It's a very, very important concept. Now, if input waveform is given and the impulse response waveform is given, then you have to simply convolve these two waveforms to get the output response of an LTI system. So what is needed? Convolution is needed. So in this chapter, what we will do is, how do you convolve two waveforms? Actually, convolution involves operations like time reversal, time shifting, multiplication, integration. If you are dealing with continuous time signals, it deals with what? Time reversal, time shifting, okay, multiplication and then integration. If you are looking at the discrete time systems, then instead of integration, you will simply have a summation. Okay, so how do you do the convolution? What are the properties of convolution? In many of the questions, just by understanding the properties of convolution, you can answer. Like, if you convolve two waveforms, if you know what's the starting and the ending points of the resultant waveform, you can answer some questions, Area property. So there is something called as area property of convolution. So if you know that, you can even answer some questions. Now there are some properties like shift property, okay. So scaling property, if you know these things, then you can answer many of the questions. So you have to definitely spend good amount of time on mastering this. How do you convolve to input waveforms? I mean, not input waveforms. How do you convolve to waveforms? This is what you have to master. And then the properties of LTI system. What properties you will learn here is, just by looking at the impulse response, just by examining the impulse response, you can decide whether a system is causal or not, whether the system is stable or not, whether the system needs memory or not. How is this possible? Just by looking at the impulse response, you can comment about these things. So this is what we cover in this properties of LTI system. The next one, using step response of LTI system. That means if I give you the impulse response, how do you find the step response and vice versa? Okay, so this is what we discuss here. Along with this, you should also know, suppose if systems are connected in cascade, how do you find the response due to this cascaded systems? If systems are connected in parallel, what could be the overall output response? So you should also learn those things in this chapter. Apart from this, you should also learn what are eigenfunctions. What are eigenfunctions and how do you find the response due to an eigenfunction input? Okay, what is an eigenfunction and how do you find the response of an LTI system because of this eigenfunction? So these are the things that you have to cover in this second section. Let's move to the next section, that is Fourier series. So the Fourier series topic deals with the periodic function analysis. What is Fourier series? It is a representation of a non-sinusoidal periodic function. Non-sinusoidal periodic function in terms of sinusoids. Okay. So now what are we going to see in this Fourier series? You have to learn about trigonometric Fourier series. How do you find trigonometric Fourier series coefficients? That is A0, AN, BN. So how do you find them? Now, apart from that, if you focus on the symmetries present in the waveform, symmetries like even, odd, half wave symmetries, then you can easily find the trigonometric Fourier series coefficients. So this is what you have to learn, and the extension of this trigonometric Fourier series is polar form. Okay, so what is the polar form of Fourier series? You have to learn about that. The extension of this is complex exponential Fourier series. What is the next topic? Complex exponential Fourier series. So we have to define what is complex exponential Fourier series. what is the relation between the complex exponential Fourier series coefficients and trigonometric Fourier series coefficients. So there is a relation between the two. So if you can find the complex exponential Fourier series coefficients, then from that, for example, if you know Cn, then from Cn you can obtain C minus n. With the help of Cn and C minus n, you can find An, Bn. So with one calculation of Cn, you can find C minus n and then An, Bn. So this makes our analysis very, very simple. We will also draw the magnitude and the phase spectra of these coefficients. And after that, we will see the properties of Fourier series. We will see the properties of Fourier series. Now from here onwards, there is a pattern in our subject. You will understand as we progress. What are the properties that we are going to see here? So look at the properties. So I'll name few of them. Properties like linearity property, anyway I don't want to write. So time shifting, frequency shift, okay, time scaling, differentiation in time, and the most important property, that is the Parseval's theorem. Parseval's theorem. Now this Parseval's theorem, in Parseval's theorem, we have a relation between what? We have a relation between the average power present in the given waveform and the Fourier series coefficients. So it relates what? It relates the average power present in this periodic waveform with the Fourier series coefficients. There are other properties like multiplication, convolution, which anyway we are going to learn in Fourier transforms as well. So these are the main properties in the Fourier series topic, right? So trigonometric Fourier series, complex exponential Fourier series, properties of Fourier series, and then the existence, what's the condition for existence of Fourier series, where you have to learn about Dirichlet conditions. You have to learn about what? Dirichlet conditions. And the other important topic is, suppose if I give you periodic input to the system, how do you find the output response? So I'll just write systems with periodic input. Systems with periodic input. So how do you find the output response of a system whose input is a periodic signal? So this is what you are supposed to cover in this Fourier series topic. What next? The most important, the heart of this subject, that is Fourier transforms. Now in this, we will first define what is Fourier transform. Okay, so let me write it in detail. This is clearly about continuous time Fourier transform. That means in the time domain, okay, the signal is continuous. For such signals, how do you find the Fourier transform? What is the condition for existence of Fourier transform? So that's what you have to learn. And then Fourier transform of standard signals. Okay, Fourier transform of standard signals. The next one is the properties of Fourier transform. Now this is the part where we are getting more and more questions. Okay, if you can understand this, if you can prepare short notes of these properties, it would be really good. Okay, I'll just list out the properties, which is like same properties we are going to discuss for Laplace, Z transforms, DFT and so on. So let's look at once the properties of this. The first property is the duality. So we are supposed to learn about duality. The next property is area property. So what do I mean by area property? If they ask you what is area of x of t, then what you are supposed to do is, if they are asking area in one domain, look at the other domain at origin. Okay, so if you want to find area in one domain, then it's better to look at the other domain at origin. So we have got those kind of properties, right? So duality, area property. Next, time shift, frequency shift, and then time scaling. Now, if you can understand this time scaling, there will be a special case, that is time reversal. Okay, so I'm not just not writing it. So you'll also learn time reversal here. So these are some of the properties. Let me list out few more. So we have many properties here. You have similar properties in the other topics as well. So that's why I'm listing them all of them at one place. And the next one is differentiation in time. You will have differentiation in frequency, differentiation in time, differentiation in frequency, multiplication in time, okay, and then modulation. This particular topic, that is the modulation property, is going to be very helpful for understanding the communication subject. Okay, so multiplication, modulation, the most important one, the convolution. Let's see few more properties. Okay, so we have plenty of them. Let me list out them. So these are the ones that you are supposed to prepare. Integration. And this order is also important. Okay, integration in time. This integration in time is just an extension of this convolution property. Okay, integration in time. So we have few more properties like conjugation, okay, and then correlation. Maybe I should have written cross correlation. Okay, let's write cross correlation, and then autocorrelation. Okay, so these are the properties, and the most important one, like in the Fourier series also we have highlighted, na? So what was that? Parseval's theorem. So you also have Parseval's theorem here. So let's include that. And extension of this, which we call as Plancherel's theorem. So let's write that. Similar properties you will see in Laplace, next DTFT, Z transform and DFT. So you have to understand this. If you simply memorize this, it is of no use. You have to understand all these properties. So these are the properties that you have to cover from this Fourier transforms. So what's the first thing? You have to learn about the definition of Fourier transform. What's the condition for existence of Fourier transform? Fourier transform of standard signals. Properties of Fourier transform. See, I have listed all these properties. So you are supposed to learn about these properties. And then what's the condition for distortionless transmission of a system? Okay, what's the condition for distortion transmission in a system? This is what you have to learn. Hilbert transform. How do you find Hilbert transform of a signal? Again, this particular topic is going to be so useful for communication, especially for EC and instrumentation. This is going to be very useful. And then we'll discuss what is correlation. See, here I have listed correlation, right? Cross correlation, autocorrelation. Now, how do you relate, or what's the link between correlation and convolution? You have to learn that as well. What's the relation between correlation and convolution? Okay, so what next? Sampling theorem. Okay, so this is also, for exam point of view, this is most important. So what's a condition for the Nyquist rate? You have to learn here. So these are the things from Fourier transform. So let me quickly tell you what are you supposed to cover. What's the definition? What's the condition for existence of the Fourier transform? Properties, which is most important part. Distortionless transmission, what's the condition for that? Hilbert transform of a signal, how do you find it? Okay, correlation and sampling theorem. So this is also one of the most important thing. Okay, so this is about the Fourier transforms. Let's extend this. Okay, so let me look at some of the comments. So I'm just reading your comments. Mamta Agrawal, I'll try to answer this general doubt at the end. Rahul, I'll try to address these things because it's not related to the present discussion. I'll try to address them at the end. So let's continue the discussion. So this is about the Fourier transforms. Now we are going to extend this Fourier transforms, which we call as Laplace transform. So now what are we going to see here? What's the definition of Laplace transform? What is the R.O.C condition? Many students, what they do is they just learn definition. They'll try to apply the definition on various signals. That is completely wrong. You have to first understand what is this R.O.C. R.O.C stands for region of convergence. How do you find the R.O.C for any given signal? Okay, so if R.O.C is not defined, you cannot define the Laplace transform. Okay, if R.O.C does not exist, then you cannot define the Laplace transform. There are questions based on R.O.C as well. What next? Properties of Laplace transform. Just like, okay, so yes, Laplace transform of standard signals and then properties of Laplace transform. Just like you had properties of Fourier transforms, right? Similar properties you will have for Laplace transform as well. So now I will not list out all of them. I'll just write the ones which are new, okay? So ones which are different, like initial and final value theorem. Like initial and final value theorem, and then unilateral Laplace transform. This unilateral Laplace transform especially helps us to find the response of the system because of the initial conditions. This helps us to find the response of the system due to the initial conditions. So you have to learn what is unilateral Laplace transform and how do you find the response due to the initial conditions, which we also call zero input response. So how do you use this unilateral Laplace transform to find the zero input response is also an important discussion. So these are the things. Let's look at this. Causality and stability. Now if you look at the second chapter, we said here the properties of LTI system. If you give me the impulse response of the system, I'll examine the impulse response and I'll tell whether the system is causal or not, whether the system is stable or not. Now we have even more easier conditions to tell about causality and stability. If you give me the transfer function of the system, just by looking at the poles or just by looking at the R.O.C, I can comment on the causality and the stability of the system. So based on this also you have many questions in the exam. What next? What's the relation between Fourier transform and Laplace transform? Like I said, this extension of Fourier transform is the Laplace transform. So how are they related? So this is what we are going to discuss. So even this is also the most important topic. Okay, what next? So we are done with Fourier series, we are done with Fourier transforms, we are done with Laplace. I also highlighted the special properties like initial and final value theorem and finding the zero input response. Okay, zero input response, that is the response due to the initial conditions. Okay, so we have few more properties like how do you find the Laplace transform of periodic signals and so on. Okay, so these are the important ones. the next topic is DTFT. Just like we had CTFT, we also have DTFT, that is discrete time Fourier transforms. So have a look at it. Discrete time Fourier transforms. So what is the definition of DTFT? What is a condition for existence of DTFT? Okay, how do you find the DTFT for the standard signals? What are the properties of DTFT? And then we will look at the digital filter response. That means if I give you a transfer function, you should be in a position to tell about what kind of filter is it. Is it a low pass, high pass, band pass, and so on. So looking at the transfer function, we can decide about the nature of the filter. Okay, so we should also discuss, you should also learn about the linear phase, FIR filters. So this is also an important topic. The extension of this is the Z transforms. Just like I said, the extension of Fourier transform is Laplace. In the same way, the extension of DTFT is Z transform. Now what we will discuss in Z transforms, try to guess it. We will discuss about the definition. The R.O.C. How do you find Z transforms for the standard signals? The properties of Z transforms. Like I discussed these many properties. So in the same way, you also have the properties of Z transforms. So most of them are in the same way. So those properties you have to learn, and especially all these properties, if you can make short notes, then that will be a very good resource for your preparation. So just like you said, from the transfer function for a continuous time system, just by looking at the poles and the R.O.C, you can decide about the causality and stability. Here also, for a discrete time signal, just by looking at the transfer function poles and R.O.C, you can comment on causality and stability. And after that, realization of digital systems, where we talk about the direct form 1, direct form 2, parallel and cascade structures. So this is what we have for Z transforms. The next topic is DFT. Now when we have all these transforms, what is the need for DFT? So the first thing you have to learn. So what's the need for DFT? So this is about DFT and FFT. So how is DFT defined? How do you find DFT of standard signals? And then the properties of DFT. Now you see all this. Everywhere I'm talking about properties of the transform. If you can write all those properties at one place, that is the biggest resource for you. Okay, and then the advantages of FFT over DFT. Advantages of FFT over DFT. So you have to see this. Now I said for EC people and electrical people, we don't have this FFT. However, if you are preparing for various exams like ISRO, BARC, DRDO and so on, you have to learn about FFT. How is FFT advantage over DFT? So you have to learn about that. So this is about the syllabus, and we have one more topic which is very, very important for engineering services point of view. So for ESE point of view, this is the important one. The digital filter design of IIR and FIR filters, where you will learn about the impulse invariance technique, and then the bilinear transformation, Chebyshev filters, okay, Butterworth filters. So we'll learn all this in this section. So this is a separate topic and especially important for ESE preparation. Okay. So what I have covered so far is what are the things that you have to cover for GATE and ESE preparation for signals and systems point of view. So these are the various topics that you have to cover. What next? I'll talk about the reference books. So what are the reference books? So let's look at them. Signals and Systems by Oppenheim, and then Analog and Digital Signal Processing by Ashok Ambadar, and then Signals and Systems by Tarun Kumar Rawat. So these are the standard books. Apart from this, I strongly recommend you our ACE Academy textbook. Our ACE Academy textbook. We have been updating that from 26 years. We have been updating that. So we have covered the various contents. We have taken questions from various examinations. That is a biggest resource for you. I seriously suggest you to solve each and every, like even solved problems and unsolved problems from our academy. Okay, and the other thing is the PYQ, the previous year questions of GATE and engineering services. So these are the resources for you. So this is all about the syllabus, the weightage, the order in which you have to prepare, and the reference books. What next? Okay, what next? The next thing is you are supposed to like prepare all this, solve the questions from the textbook, okay, and then solve the PYQ book, write the mock exams. Then you are ready for your exam. Okay, then you are ready for the exam. So I would like to highlight few more things like short notes. So it's a very, very important one. Now students often ask us, sir, how do you write short notes? Or they even ask us, sir, please send us the short notes. Please send us the short notes. If you are really like hungry and if you ask the other person to eat and you say that if you eat my hunger will go down, will that happen? No. If you are hungry then you are supposed to eat. Okay? If you want to really crack the exam then you are supposed to prepare this short notes. Okay, if you are really hungry and if you ask someone, like you are thinking like if someone eats, then your hunger will go down. It's not possible like that. In the same way, you have to prepare your own short notes. So the common doubt is, sir, how do you prepare short notes? See the way I have written this. Look at, I said, write the definition and then the properties of DFT. How is FFT advantage over DFT? If you can write this, hardly it will take 10 pages. Okay, so writing short notes is also important because in the let's say you have a month, how can you revise all these contents in just 1 or 2 days? But if you have a short notes, a 10-page notes or a 15-page notes, you can easily revise them in 1-2 hours. So I recommend you to write short notes. The next thing is the mock exams. Students spend lot of time, lot of time. Okay, lot of time in what? Lot of time in listening all these lectures. They spend time in solving the questions. They revise, they follow various academy books. Okay, but what they forget is writing mock exams. They forget writing topic-wise, subject-wise. They feel as if I'll write all these exams just 1 month before. All these exams. How is that possible? So from now onwards, you have to write exam every day, either in the form of a topic wise or a subject wise or 2-3 subjects together. Okay, right? So what is important? Writing mock exams is important. Okay, now let me also give you some of the frequently asked questions from the students. Now I come across these kind of questions. Sir, how many times should I solve PYQ? Should I solve it once, twice, thrice? How many times you will solve? You have to solve only once. Only once you have to solve. Why are you wasting your time on solving it multiple times? If you find any difficult question, then you have to mark it. Maybe solve that twice or thrice. Right? I don't recommend you to solve PYQ many number of times. Only once you solve. Difficult ones you highlight and then again you try to solve them. So this is the frequently asked doubt. And the next doubt I'll just show you. Recently, I've got a doubt from a student. Look at this doubt. I posted it on the screen. He says, sir, I was doing problems in core as well as in max. I'm able to get the normal questions or the standard models right, but there are some questions in every gate year which is completely out of box. Especially from probability, complex variables and analog circuits, he says. How to deal such new model questions in the exam? This is the doubt posted by the student. Right? Then I said, okay, let's have it, I'll answer this. So I called him, okay. So I asked, when did you pass out? He said he passed out in 2018, okay. Then I said, what were you doing? He said, I'm working in TCS. Okay, he was working in TCS. His package was 3.5 lakh per annum. Okay, when he joined, it was 3.5 lakh. And from 2018 to 2021, I suppose, he was working as well as preparing. I think in 2020, he resigned and he completely dedicated. So he gave 2022 exam. in which he got 40 or 45 marks. His rank, he was from electrical engineering, his rank was 4,000. How much was his rank? 4,000. Right? So look at this guy, what is he saying? He says, there are some questions in every gate which is completely out of box. He has mentioned some topic names. Then I asked, did you go through these topics? Yes, he said he understood all this. I asked him, did you also solve the previous questions? Were the previous questions were also difficult? He said, no, they were actually easy. So what's the conclusion? The conclusion is that in every gate exam, there will be definitely a few difficult questions. In fact, I asked him about this probability question, which I was also interested to solve. It took nearly 15-20 minutes to solve. Frankly, I'm speaking. It was little twisted. I took some time. I answered it, but I took time. Now, what happens if you try to solve such questions which are really tricky? You are going to spoil your paper because you are wasting your 15-20 minutes on a question. So you have to understand that in every gate exam, there will be some questions which are out of the box. Don't touch them. Right? Don't touch them means how you will know that these are tricky. That's where this mock exams play a crucial role. The more mock exams you write, the better judgment you will get. Just by reading the question, maybe half minute or 1 minute you will go through it and you will be in a situation to decide whether to solve it or not. You can easily decide. So what is important is writing the mock exams. Even after preparing all these topics, you don't write the mock exams, then you will not feel comfortable in the examination hall. So you have to create an exam environment that is possible only through mock exams. So I strongly recommend you to write many exams. And let me also tell you what's the feeling of the student. Now when they start writing the mock exams, initially the first 2 or 3, 4 mock exams, if they score very low, you don't worry about it. It will take time. It will take some time for you to improve. You have to work on your mistakes. So you have to write as many mock exams as possible. You have to correct your mistakes. Right? Self-motivation is also important. No one will motivate you. You have to motivate yourself. So these are the things in today's discussion. In tomorrow's discussion, we will take some important concepts of Fourier transform. So tomorrow I have an interesting activity. So I want you people to participate in that session. So that's it for today. Okay.